Okay, can we see my screen here appropriately?
Yes, sir.
Awesome.
Yeah, we got you.
All right. Well, thank you, Monson, for inviting Emesent to present today. I'm, like you mentioned, Doyle McDonald, Business Development Manager for Emesent, and I'm going to go over our Hovermap solutions today. Essentially, I'm just going to go through our latest product offerings on the Hovermap and then just talk about the workflow itself. But as a little bit of a background, I'm going to touch on Emesent as a company. Founded in Brisbane, Australia. It's jumping on me. Okay. We have multiple headquarters across the world, so very worldwide company. I know here in the Americas that can be met with trepidation at times. I know for one, just being on the sales side of things, working across time zones, especially when it comes to customer support or sales for that matter, that can be a bit intimidating. But not to worry, we do have a Denver-based headquarters now. So all customer support, sales, and soon to be engineering from a maintenance perspective is going to be done in our Denver headquarters. So a little bit more about Emesent as a company. It's kind of rise to the Hovermap solution we have today. This started out as a spinoff from CSIRO Research. So the Australian government had been working on some algorithms with autonomy. So we're a spinoff from that. And basically, our solution in general is going to be, the focus point is going to be our SLAM-based LiDAR. This is particularly where we kind of come from a background of mining. So in mining, GPS-denied flight is going to be our number one problematic area. So being able to fly or think on behalf of a drone underground is top of mind here. We have various different degrees of autonomy. One of our levels of autonomy is going to be collision avoidance. I'm going to touch on that a bit later, but with our Hovermap sensor, based on the return it's seeing, it's the eyes and ears, so to speak, for the drone underground. And it's going to correctly map its environment and then avoid, any obstacles or, challenges that might be in that environment. We have an advanced level of autonomy, which is when you're going to be dropping waypoints on a tablet, and the drone itself is going to pick the path of least resistance. So a little bit more on the Hovermap itself. We have two different models that are available right now. It kind of goes back to the sensor, but really what it starts with is, getting reliable data. So creating this point cloud. What we want to do is highlight our Hovermap, which is going to be a rapidly deployed system to create that point cloud. There's a slide a little bit later. I'm going to showcase the different ways to deploy this, but you're going to be capturing that point cloud, and you're just going to layer over the data on itself and develop that digital twin. So the number one problem is GPS-denied environments when we have to get these point clouds. Going back to our kind of growth in the mining industry, underground, perfect example of a GPS-denied environment. So what we did is come up with this solution to one, be able to quickly deploy the product, our Hovermap, but then this advanced level of autonomy is going to be able to map the unknowns. So where it's dirty, dark, or dangerous, it doesn't matter. That's where we're going to have our robotics take over and be able to map that area. To sum it up, there's going to be one deliverable, but we can merge with multiple scans. How we're getting those scans, there's various different methods. So this bridge, for example, we've got a digital twin here. This is actually 6 total scans. We started off with being the payload on a M300 DJI. We're fully integrated with a few different DJI products. So we flew over the top of this bridge. There was 2 different scans from that standpoint. And then what we did is using the quick disconnect, we popped it onto our handheld mode. And what that is we just mount it on a backpack and merely just walk across the bridge. Right there, that was sufficient, getting that dense point cloud from above. And then below it, we actually used our suction cup mount for the hood of a car and drove underneath it. In some of those problem areas, you can see some of the rocks down below, a little bit of a foliage there. We walked and did a hand scan as well. We export those, and using our Emesent software, the viewer, it's just going to consolidate those scans, and using those the different points of interest that the scan picked up, and it's just going to layer those right on top of each other. So I'd kind of mentioned earlier the different hover maps that are available to us right now. So our Hovermap ST, this has been around for almost 2 years now. This utilizes a Velodyne sensor, and you're going to get 600,000 points per second return. The effective range is about 40 to 100 meters. We think that 40 to 50 meters is the sweet spot to get the best return and the highest density of your point cloud. You do get that return from 100 meters. It just might be a little bit more fuzzy, and it's just a little bit more sparse when you're getting that return. This is actually rotating 360 degrees. So when it comes time to processing, you're actually just going to remove the immediate, kind of near, how do I put it, the returns that you're getting. So, if you're handheld, you're actually painting the side of the building, you're just, kind of using this as a magic wand of sorts. You're going to remove all the points in the return, that might be out 1.5 meters. Something to note between, our Hovermap STX, which is our newest model, and this one, the only changes in the sensors. So something that's come up is accessories are going to be forward compatible with our newer products. Essentially the bones of the Hovermap is going to be the same. So there's a 500 gigabyte hard drive where it stores all of the point clouds on board. It actually emits a Wi-Fi signal, so you can follow along on your tablet, phone. You can actually see in real time with a decimated point cloud what you're actually scanning. At 1.6 kilograms, that's noted. More often than not, this is a payload on various different things. A drone where payload and weight is important to note. So getting to our Hovermap STX, I mentioned earlier, the only change is primarily going to be the sensor. This utilizes the Hisai sensor. You're going to get a return of 1.9 million points per second. We're going to get considerably, more return from a longer range. So we actually advertise this out to 300 meter range. It's pretty remarkable on the accuracies that we're getting with this newer sensor. Triple return. This has been a very big interest in penetrating, a vegetation, dense canopies. That's where that triple return is actually going to, really be a game changer from that standpoint, and getting the returns and seeing that ground level penetration. Outside of that, it's going to have the same 500 gigabyte hard drive. We've made some minor improvements, namely, that piece of hardware itself is just going to be a little bit lighter than our STX. So a huge point that I want to drive home is that you're essentially, you're going to receive a product, the Hovermap itself. This is various different tools. We're fully integrated with various different platforms. The goal is to be absolutely agnostic on what platform we put it on. Right here, you can see the Boston Dynamics Spot. We're fully integrated here, so you can use our advanced level autonomy with Spot. Changing between the different ways to deploy it, it's just a quick release mechanism. So it's just 2 thumbs, and you're going to snap it off, and you can, put it on whatever next by any means necessary to capture that point cloud. That next image, you're seeing it with a handheld mount. It's an accessory that comes with the our Hovermap kit. And then the next image, you see our backpack. Sometimes it requires an easier way to deploy. You want to be hands-free. A lot of the times that person actually uses a tablet in their hand. They could see exactly the environment that they're scanning right there. Along with the backpack just being a really great way to transport the device, you can actually clip in additional batteries for extended battery life. Up next, we have our stainless steel cage. In a manhole situation, you could just drop this down on a cable. It's actually quite sturdy, quite heavy. It can bump and navigate the way, if it might not be something that's necessarily mapped. This is especially the case in, mining applications where you're going to need gravity to do its thing. You have essentially a 40-pound weight at the end of that tether. And then, of course, I've been speaking to the drone application. We can use our advanced levels of autonomy with the drone. If we're not fully integrated with that drone manufacturer, it can still connect to the drone, and you're getting, your point cloud. You just might not be using that level of autonomy. And lastly, that's actually I think it's a magnetic mount. It's a bit tough to see. Hopefully you can see it on your end. But we have magnetic mount and suction cup mount. It's important to note, for the most part, we're capturing this data, at 5 to 7 kilometers an hour. We've actually been kind of under-promising the full capabilities of our STX model with that new sensor. We've actually, one of our founders put it on the hood of his car and drove 100 kilometers an hour throughout Australia, and it was pretty impressive the type of return he was getting even at that speed. So multiple different ways to deploy this product. I just want to drive home that with this, you're getting multiple different use cases. So, it's an extremely versatile product. When it comes to, the levels of autonomy, I'm going to touch on that in the next slide. So we do have 3 levels. Autonomy level 0, essentially we call this mapping mode. You aren't going to be used that advanced, autonomy. It's just picking up the immediate environment using the sensor. Autonomy level 1, this is what we call pilot assist mode. You're creating a VESH, which is a vertical elliptical shield. It's essentially an invisible bubble that surrounds the drone itself, or it might be a spot, for instance. You're going to determine your risk appetite. So if you want a 2-meter bubble around your device, or maybe it's only 1 meter, you can set that as a standard for that mission, and just making sure that you're detecting all of the objects around you. So it will detect, based on the sensor, it's getting a return, things down to 1 millimeter. I'll highlight that in the video here shortly. And so that would be AL level 1. Autonomy level 2 is you're actually thinking on behalf of this, of the drone itself, using the SLAM-based LiDAR. So simultaneous localization and mapping. It's determining the environment around, using that advanced algorithm, using and the return it's getting. It's determining what is exactly in its immediate surroundings, and it's going to pick the path of least resistance on the waypoints that you're dropping on the tablet itself. Sounds a bit complicated. You'll see it in real time here on the next screen, but this enables beyond visual line of sight flying, just picking those waypoints and letting the hover map direct the drone where to go and pick up that point cloud. Now, been hit and miss for me in the past. Hopefully someone could, in the chat, just let me know if the sound is coming through.
No sound, Doyle, but we're getting the gist of it here.
Okay. I'll try and narrate the best of my abilities. Just muting it on my end. So what Jeremy, one of our, he's our senior pilot here for Emesent's doing, he set up a obstacle course. This is using AL1. Oh, no, I'm sorry. This is actually advanced. This is AL2. It's our full autonomy. Those are 1 millimeter wires. So in a sense, he set up an obstacle course. This culminates in actually an obstacle that you cannot get by. There wasn't enough room based on the VESH levels. So on the right side of my screen, you can see the tablet display. That's that vertical elliptical shield, or kind of the invisible bubble around the hover map itself that was set up. And that's what you're seeing in real time. In AL2, he's sending it on a mission beyond visual line of sight, and it's showcasing some of the obstacles in its way using that algorithm. On the next screen, I'm going to, so this is where he had multiple different, 1 millimeter wires coming down, and the hover map itself determined there was no clear path forward. And that's where, there's various different fail safes. But if there is no path forward, it's going to return to its last known point or its last known places that it landed. In the event that you're getting total communication loss, the hover map with those advanced fail safes is going to return home. So here's autonomy level 2, what this looks like. You're using the tablet. We sell a third-party tablet, or I mentioned earlier that there's actually a Wi-Fi signal that's being emitted from the hover map. You can pull it up on your iPhone or whatever phone you might have. You log in, you can set your waypoints. Right now, this is creating the mission. This is Emesent's proprietary software right here. You're dropping waypoints on the screen, and that's where, using the advanced level of autonomy, it's going to find the path of least resistance for that drone to pick up the point cloud. This is it's important to note this is a decimated point cloud. You just want this in real time. It's especially important when you're out in the field. You don't have this level of communications, and there's no uploading to the cloud. And figuring out exactly what you have or have not mapped is pretty essential. A lot of times we've spoken with end users, and when they're traveling hours to go out into the backcountry, wherever it might be, the idea is not having to go back again. So this enables true beyond visual line of sight. Quickly go through these. So multiple applications. I showed the different ways that you can attach this hover map as a payload. It's pretty much whatever you want to get a digital twin of. You're available to. They're just with the multiple methods of deploying this in the field. We do offer colorization. We use that with a GoPro. I have a couple examples here at the end. So this is a fly-through on an oil rig scan. Based on the intensity readings that we're getting from the sensor, that's where we're seeing the color from this standpoint. In terms of accuracies, we can expect to see anywhere from 10 to 12 millimeters. We do have a way to tighten that up using ground control points. So it has reference. The hover map itself has reference to snap to a grid. Typically our scans, one of the best parts about our product is the ability to get that point cloud very quickly. For instance, if you're walking around for 15 minutes, a 15-minute scan would typically take 30 minutes or less for processing using Emesent software. You're going to just drag and drop all the files. It's going to associate the different point clouds together, and you're going to come up with your full scan. I want to allow enough time for questions and answers here at the end. So I was kind of touching on the workflow. You're going to get that point cloud by any means necessary, fly, walk, drive, tether. That 500 gigabyte hard drive that's stored on the hover map itself, you plug in your hard drive, the software itself, the software knows exactly which scans have already been offloaded. Once they've been offloaded, it actually keeps them on board in the event that you need to pull them off again, but it will cycle through the latest scans that haven't been downloaded and put those on your USB drive. When it comes time to processing data, you're just going to plug that hover map, the thumb drive right into your computer. This is all done locally on site. So it's important to note that in secure environments, that none of these scans are actually being uploaded to the cloud. It's all in a secure environment and can be done in GPS, Could be done in wide, anywhere, any environment where there's no communications or an ability to communicate can be done right there in site. Again, this kind of goes back to our mining background and figuring out what's practical. Using our Emesent software, so once you're processing that data, you're just going to export it in whatever file type of you're choosing. We try to be as agnostic as possible on what we're integrating with, as well as what file types might be being used with our end users. This is another fly through, just a big digital twin. So I spoke to colorization earlier. This is a colorization scan. We utilize a GoPro. What it does is it pixelates that GoPro and it attaches, our software will automatically attach it to the point cloud. And that's going to be dragging and dropping our Emesent software. With our Emesent software, you automatically get our ground control point in georeferencing. So if these are known points, you actually are going to plug them in using an Excel file. What it does is these ground control points, they can be any size. We sell them at 50 centimeters. You can create them as well. Your end users can invest in this. What it does is it uses proprietary 3M tape. That reflectivity is automatically picked up by our software, and it recognizes that as a ground control point. You just use your XYZ, plug it into Excel, and then you're already going to have your referencing right there in our software.